Alright, so what's a mapping, first of all? A mapping is when I take an input, say it's 3, and then I'm going to apply an operation to it to produce an output based on that input. So maybe my mapping in this case is 3 times the input, and we're going to get 9, because 3 times the input, which is 3, produces the output, which is 9. 3 times 3 is 9. Very simple. I might have add 2 to the input, where our input is 2, and then I would get 4 because 2 plus 2 is 4, and the output in that case is 4. So we can look at this graphically. Y equals x, that is a mapping because it's just giving the same output for the same input. Y equals sine of x, that's just a trig function. Y is going to be the sine of x, so the output is the sine of the input. Here, y squared plus x squared is r. This is a bit special, but I'll get back to that. Mappings are called one-to-one, many-to-one, or one-to-many. So if a mapping is one-to-one, then for every input x, there is exactly one output y. So look at the graph of y equals x. For every x here, every x value along this axis, we have exactly one y value corresponding to it. We can have many-to-one mappings. This is where for every y value, there are multiple inputs that can produce that output, okay? So now we have one-to-many, that's where one input can produce many outputs. Okay, so this measures relative to an input, how many outputs are produced. Many-to-one means many inputs produce the same output. One-to-many means one input can produce many outputs. And one-to-one means one input produces one output exactly. Every value that a mapping can take as an input, that set of values is called the domain. So for example here, y equals x, the set of values that this can take in is just basically any real number, okay? It's just x, or really any number, because it's just going to give, the output is just the same as the input. So this can take anything in. So we can say its domain is just, you know, anything. It's basically just anything. Here, y is sine of x, so what values can this take in and give us a valid output? Well, this can take in basically any real number, okay? Sine of x has a value for every real number, from negative infinity to positive infinity, it's all defined. So the domain of the mapping y equals sine of x, the domain of this is all real numbers, because you can have any real number as an input and still get a valid output. Now, if we're looking at y squared plus x squared, we might want to rearrange this and say y squared equals r, this should be r squared really, equals r squared minus x squared. And in that case, then we can say, well, x, our input x and our input y, we've technically got 2 inputs here, but it's also 1 output, 2 outputs. You don't really need to think about this at A level or GCSE, so don't really worry about it. It gets really complicated. More importantly, after the domain, we have range. Range is the opposite of domain. So if domain is the set of inputs, you know, like for example, all real numbers for y equals x, or all real numbers for y is sine of x. If domain is the range of inputs that a mapping can take, then a range, okay, domain, you're going to have to live with this handwriting, all valid inputs. Yep. Then range is all possible or all valid outputs. So range is the set of all values that a mapping can produce, and the domain is the set of all inputs that the mapping can take to produce one of those outputs, or many of those outputs in the case of a one-to-many mapping. Now, the last thing to know about mappings is that there is a special type of mapping which is called a function. A function has a couple prerequisites. We can look at these right here. Let's say we have this mapping, y equals x. Is this considered a function? Yes, this is a function. So let's tick that. Y equals sine of x. Is this a function? Yeah, that's a function. Let's tick that. Y squared plus x squared equals r squared. Is that a function? No, that's not a function. So what's the difference between these? A function is a specific type of mapping which has to obey the following rules. First of all, for every input in the function's domain, there has to be exactly one corresponding output in the function's range. So this cannot be a function, because if I say x is 0, then I'm going to get two possible y values, okay? I'm going to get a y and I'm going to get a negative y as possible outputs. So there are two outputs for every input. Therefore, this is not a function, because there is more than one output for one of the inputs. Y equals sine of x, this is a function because every input has exactly one output that comes out of it, and y equals x is a function because every input has exactly one output that comes out of it. Now, there is another case of this. Let's say I have y equals 1 over x, okay, just a reciprocal graph. Then this can still be a function as long as you set its domain to be x isn't 0, okay? Because 1 over x, if you have 1 over x at x equals 0, you're going to get 1 over 0, which is undefined. This is not allowed. This is illegal in maths, and the police will pull up to your house and arrest you if you attempt to write 1 over 0. So this cannot be a function if you allow x to be anything, okay? If the domain of this is not x equals 0, if you don't define the domain as x isn't 0, this isn't a function. As long as you say that the domain is x isn't 0, then you're good, okay? Because the rule is that for every input, so for every value in the function's domain, there needs to be exactly one corresponding output in the function's range. That's the simplest definition. You can still have, so you can have 1-to-1, okay, one output for every input, and you can have many-to-1, you can have many outputs for every input, but you can't have 1-to-many and have it still be a function, because then there is not exactly one output for every input, okay? Multiple inputs can have the same output, that's completely fine, because still every input has an output, but in 1-to-many, an input has two outputs. You can't have two, and you also can't have 0 outputs, okay? That doesn't work, that's illegal. So you might have another example of a 1-to-many function quickly. Let's say I have the square root function, would be another one. If I have a square root function, it would actually look something like this, okay? Because there's going to be a negative square root of every number. So this is considered 1-to-many. We can't call this a function. But if I were to erase this and call it the principal root, okay? So now you can only have the positive square root. This is the principal root. Then this is 1-to-1, so this is a function. Because every input in the domain, which is x is greater than 0, okay, for every, where did my pen go? For every input in the domain, which is x is greater than or equal to 0, sorry, there is one output, so it's fine. If I add this, then there's suddenly two outputs for every input in the domain, okay? So that's not allowed. Similarly, if I were to remove this domain restriction and I were to just say x is a real number is the domain, this is illegal, okay? You cannot do this, because if x is a real number, then x can be less than 0. There are no outputs. For any input where x is less than 0, there's just no corresponding output. You can't take the square root of a negative number unless you're doing complex numbers, which is beyond the scope of this video. So because the mapping would be undefined for a value within the domain, there's no output for in the range for an input in the domain. That's not allowed, so this is no longer a function, it's just a mapping. All functions are mappings, but not all mappings are functions. I finally said it right, okay? Not all fingers are thumbs, but all thumbs are fingers, okay? For something to be a function, it's necessary that it must be a mapping. Those are all the examples. Yeah, that's it. Okay, thank you, goodbye.